Hello, this is Mr. Henry, and welcome to lesson 4.1. We are starting a new unit that is devoted to lines. So we're going to be finding slope, we're going to be finding rate of change, we're going to be graphing, we're going to be writing the equations of lines, we'll be converting equations of lines in different forms. So a lot of stuff that has to do with lines, so let's get to it. In this lesson, the essential question says, how do I find the slope of a line and interpret the slope as a rate of change? Okay. Did you know that the slope of some common objects make a big impact on your life? For example, if the slope of your roof of your house is too steep, the rain won't go in the gutter, it'll just kind of fly right over across the top. If the slope is too shallow, so if the roof is mostly flat, then the snow in the wintertime may collapse a roof because it would just sit on top and that bad stuff happens. If the slope of your yard is facing the wrong way, so if your house is at the bottom of a hill right here and the water is running downhill when it rains, guess where that water goes? That's right, it goes into your house, into your basement, you get wet everywhere. If a hill or a mountain, when people are doing construction, they have to make sure the hills are graded the right amount, make sure they're the right slope. If it's too steep, it can cause a landslide, something like that. So slopes, believe it or not, actually have a major impact on our everyday life. They happen in a lot of places, making sure the angles are right. And that's really what we're talking about with slope, is the angle of a line. All right, so we have two vocab words here. We have slope, and slope is how slanty a line is. And it can be found using this formula. Now, this looks a little ugly. The real formula, which is this one here, also kind of looks a little ugly. So here's what you really want to write down. The slope formula is y2 minus y1 over x2 minus x1, where these y1 and y2, x1 and x2, they come from 2 points. And the first point, you know, the first point when you have an ordered pair, the x value comes before the y value. Well, since we're going to call this the first point, we're going to call this x1 and y1. They get the ones because they're the first point. We're going to say this one over here is the second point. So now we'd have x2, y2. So when you have 2 points, this is the formula you use to find the slope. Our second vocab word, rate of change, is when you compare the change in one quantity to the change of another. This is basically saying word problems, problem solving, slope. You're comparing the change in one quantity, the change in something, to change in another quantity. So it could be the change in speed over a change in time. That would be the slope of the line that shows how fast you're moving over time. All right? So let's get into it. If you still need this a little bit longer, pause the video. I'm moving on. So the first few problems we're going to do here is we're just going to find the slope of the line that goes through these 2 points. So I've got 2 points here. Now, I remember the formula. If you don't remember, you can look back at your vocabulary page. Also, in the front of your packet, you should have a formula sheet, and this slope formula is one of those formulas. It says on the formula sheet, m equals y2 minus y1 over x2 minus x1. So for us to do this problem properly, all we have to do is figure out of these 4 numbers up here, 1, 2, 3, 4, which ones are the x's, the y's, the 1's, and the 2's. It's very easy. So it goes like this. x1, y1, x2, y2. Always. It's never in another order. X comes before y, 1 comes before 2. So it's x1, y1. This is the first point. This is the x coordinate. This is the y coordinate. This is the second point, which is why they're 2's. X coordinate, y coordinate. So now what we got to do is plug in these four numbers in the right places in this formula. So the first thing that's going to go right here is this y2 value. y2 up above is negative 4. So y2 minus y1, that's 4. Over, now I need my x2 value, which is 0, minus the x1 value, which is negative 2. Notice how I put minus negative 2? The formula has a minus, that's him. But since my number was a negative 2, I had to include the negative as well. So I have 0 minus negative 2. Now, from here, if I just do this little bit of math, I'm done. I do the math on the top, I do the math on the bottom, and I simplify my fractions. So negative 4 minus 4 is negative 8. 0 minus negative 2, we could do by hand going keep, flip, change. So now it becomes 0 plus a positive 2, which is 2. And then we simplify the fraction. So negative 8 over 2 is equal to negative 4. Now, if you have it as negative 4 over 1, that's okay. That's allowed. But just negative 4 is okay as well. That over 1 would be kind of like a ghost over 1. A lot of times when we're talking about slope, we want the slope as fractions. We do not want decimals. We do not want mixed numbers. We want a fraction. We want a ratio. One number over another number. Okay? So a lot of times, for now, I'm going to put like this ghost over 1, but know it's there, and a lot of times we're going to need that. All right, letter B. Same deal. I'm going to go through the exact same process. I'm going to write down the formula. M equals y2 minus y1 over x2 minus x1. I'm going to label x1, y1, x2, y2. I'm going to plug in y2 minus y1 over x2 minus x1, and do the math. 1 minus 7 is negative 6. Negative 2 minus 3 is negative 5. And I'm not sure if it's going to work on this calculator. On the black calculator that most of you are using, this does not actually work. If you put in, let me see here, negative 6 fraction negative 5 equals, see, it gives us an error message. All right, so the reason for the error message, the best thing I could come up with is the calculator does not like that negative in the denominator of a fraction. It freaks out, it gives you an error message. So we have to be smarter than the calculator here. So when you have a fraction, if both the top and the bottom are negative, a negative number divided by a negative number is a positive answer. So you have to know in your head that this negative divided by that negative is actually going to give me a positive 6/5. Negative on top and bottom both cancel out. So this becomes positive, positive. It's almost like when we did over here, when you have like 0 minus negative 2, minus a negative turns into plus a positive. Well, negative 3 divided by negative 4, these negatives cancel each other out and you get a positive answer. Okay? Now, 6/5. If you try to go, okay, cool, let me delete that and just go clear, clear, clear. 6 fraction 5 equals. Your calculator might say 6/5. Your calculator might also say 1 1/5. We do not want that. We want our answer as a fraction, as an improper fraction, as a ratio, as one number over another. So I'm going to leave it as 6/5. If your calculator says this, no, we want that. It doesn't make sense yet. Why? It's going to be for when we graph. When graphing, we really like our answers, our slopes as fractions. So we're going to kind of keep fractions. All right, I did too. now you do too. So I want you to pause the video, try these two problems on your own. When you are ready to continue, hit play, and we'll go through them together. Okay, let's see how we do. So formula, m equals y2 minus y1 over x2 minus x1. I'm going to go ahead and cheat right now. Copy, clone, there we go. Cheater, cheater, pumpkin eater. All right, now label x1, y1. My marker's not working. There we go. That was y1, x2, y2. All right, so plugging them in. y2 minus y1 over x2 minus x1. Check your numbers. If your numbers don't match up the exact places mine did, you probably plugged your numbers in the wrong spot. Now it's just mathing and simplifying. So math on top, -9. Math on bottom, -12. And simplify. Again, here's this negative divided by negative. You have to know that's a positive. So if I just go straight up 9 over 12, just canceling out the negatives. Boom, boom. If you still struggle with simplifying fractions, calculator could do this now. If you don't struggle with simplifying fractions, then you know that 9/12 both can be divided by 3, and you get 3/4. That is what we want for our answer. Letter D. x1, y1, x2, y2. Plugging them in. y2 minus y1. Notice I put -2. So it's 4 minus, because the formula has a minus, -2 over x2 minus x1. Math. 4 minus -2 becomes 4 plus 2, which is 6. 5 minus 2 is 3. That fraction can be simplified down to 2 over 1. So if you have 2, awesome. If you have 2 over 1, that's still good too. Now, we're going to practice finding a slope from a graph, from a picture. So basically, the way this is going to work out is we're going to look at our pretty picture. On the picture, our line, whichever line that we're drawing here, will go through, I call it these crisscrosses. Like right here, if I had a line that went right through this crisscross, the bullseye between these grid markers, that's what I'm looking for. So if I follow my line, no, yes, I'd say that goes right through, at least close enough for us. No, yes, no, yes, no, yes, no, yes. And I think there might be one more down here. Now, it should follow a pattern. Look at the pattern from one dot to the next, to the next, to the next. How would I get there? A lot of people draw stairs. Boom, 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 boom. Notice the stairs are all the same size. If you have stairs that are different sizes, you don't have the pattern right. Sometimes that happens. The stairs should all be the same size. It should be the same pattern. The slope will be, what pattern would you use to get from one step to the next? So looking at my picture here, to get from, let's just narrow it down and say from this step here, this red one, to this red one, I would go up 1 over 2. When I say over, I do always mean over to the right. So this slope, the slope of this line, is up 1 over 2. Now think about that. I use the word over 2 different ways. I mean, in a picture, going over to the right, up, over, up, over. In my fraction, when I say over, I mean over as in being the bottom part of the fraction, the denominator. So when I say 1 over 2, this over 2 is how far we go over, and it's a 2 in the denominator. This, how far the line moves in the x direction, is the bottom part of the fraction. which would make sense because in our formula, m equals y2 minus y1 over x2 minus x1, the top number is how far your line moves up and down. The bottom is how far the line moved sideways. So this is up and down. This is sideways. So from one point to the next, I went up 1 unit over 2. So my slope is up 1 over 2. Okay, now letter B. First thing you got to do is you got to find those points. No, no, yes. No, no. Uh-oh. I only found one. Well, I didn't actually start the whole way on the side, so let me go back the other way. See, that's kind of close, but I can see the bullseye right here, right above the line. It's that one. Sometimes it's pretty close. Like that one right there is pretty close, but it's not right on. Now, to get from here to here, I'm going to go down and over. You always go up and down first. So I'm going to go down 1, down 1. See how I made it negative? It's negative because my line is going down and over. How far over? Well, 1, 2, 3, 4, 5 boxes over 5. So my slope is down 1 over 5. Negative 1/5. I'm going down 1 in the y direction. I'm going over 5 in the x direction. The formula has y's over x's. Down 1 over 5. Remember, over is always to the right. Letter C. Here's a point. No, no, yes. I did not mean to write there. No, no, yes. Now if you look at the pattern, I'm going down 3 boxes over 1. Down 3 units over 1. And even though I can't see the rest of the line, I know the next point would be down 3 units over 1. It'd be right about there. It follows a pattern. Down 3 over 1. Down 3 over 1. Down 3 over 1. Do you see how saying that out loud, that pattern, can actually help you write your slope? Down 3 over 1. Down 3 over 1. Down 3 over 1. So my slope is a slope of negative 3, or negative 3 over 1. Now, if you do not like this method that I'm showing you right now, I call it the counting box method. If you do not like looking at the pretty picture and counting the boxes, if you really, really love the formula method, the formula method works as well. It is not as short. It's a little bit uglier, but it can be done. You still have to find 2 points. So let's say I find this point here and this point here. You then would need to find the ordered pair for those points. This is the point 2, 1. This is the point 3, negative 2. And now that you have those 2 points, you do the same thing we did before. You would write down your formula. M equals y2 minus y1 over x2 minus x1. We label our points. x1, y1, x2, y2. I'm labeling these ones because they come first in the line. If I'm going across my line, I get these first and these second. So then I would have negative 2 minus 1 over 3 minus 2, which is equal to negative 3 over 1. That's the same slope I had when I went down 3 over 1. And it's not a coincidence, because what this formula is doing, when you're subtracting the 2 y values, you're finding how far is the change in the up and down direction. The change from one point to the next is you went down 3 units. When you're subtracting the x values, you're subtracting how far sideways, how far apart are these 2 points. and we found they were 1 unit apart. That's the same formula we got when we counted boxes. Okay? Counting box method is a very nice shortcut method that works most of the time. There are some times it doesn't work as well, but it still does work. And we'll get to them later on, I'm sure. But in the meantime, please try letter D on your own. So you first have to copy the line exactly on your paper the way I have mine. If you have your line not exactly mine, then we may not have the same slope. Okay? So pause the video, copy it exactly, and then when you're ready to continue, hit play, and we'll go through it together. All right. So let's make sure we have our dots correct. So from the origin, to get to our first dot, you went up 3 and to the left 1. There is the first point where it's going right through that bullseye. The next one is right here, right through a bullseye. The next one is right here, right through the bullseye. Now the pattern. If you're a little dude on this line and you're walking across the page, apparently you have 3 arms there. 4, 5, 6 there. Now you're a spider. You're a spider. You're walking across the page, right? You're going from this dot to that dot. You would go down 1, over 1, 2, 3, 4. And you're going downhill. Downhill. Lines are going downhill as you go from left to right will all have a negative slope. This guy, he's going downhill. He had a negative slope. This guy, downhill. He has a negative slope. The slope here is -1 over 4. Down 1 over 4. Down 1 over 4. That's the slope. Down 1 over 4. Okay? 2 more for you to try on your own. So again, pause the video, try these 2 on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so I see a point here, and here, and here, and here, and here, and here. This line, I can tell will have a positive slope because my line is going uphill as you go from left to right. As you go from this side of the graph across, like you read a normal piece of paper, it's going uphill. Now, the slope would be from one dot to the next, I go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. That is my slope, which you could just write as 1. Now, what if, play pretend, maybe you didn't see some of these dots. Maybe you only got like, let's do like these 2 dots here. Let's say you did those 2 dots. Would you get the exact same slope that I got? Well, let's see. If we went up 2 over 2, up 2 over 2, up 2 over 2. Our slopes look different, don't they? But they're not. If you would take this, 2 over 2, and you would simplify that fraction, do you know what you'd get? 1. And it would work no matter what points you picked. If you could pick any points on this line, and if you do the same method, you get the same slope. If I picked this point here and this point here, I would go up 1, 2, 3, 4, up 4 over 4. 4 over 4. Do you know what you get when you simplify? You guessed it. You get the same slope. Okay? So you don't always have to pick 2 points that are directly next to each other. That just makes it so you don't usually have to simplify your fraction. Letter F. I got a point in the origin, I've got a point here, and I've got a point there. The pattern is I'm going to go up 1 and over, what, 3? Up 1 over 3, up 1 over 3, up 1 over 3. Slope is 1/3. That was pretty easy. So right now, if you could please, pause the video, Question says, what are two methods for finding the slope of a line? So the two methods we've talked about in this lesson, hopefully you've answered your summary for yourself already. The two methods you've learned in this lesson have been, you can find the slope of the line using the formula method. You write down the formula, you label your points, x1, y1, x2, y2. You plug the numbers into the formula, and you do the math and simplify your answer. I call that the formula method. The other way we looked at is using the counting box method, or the counting units method, where you count the boxes up 1 over 3, or down 2 over 5, to find the slope that way. Example 3. Little application word problem. Finding the rate of change. So it says here, a computer cafe charges you for using the internet. The table below shows the costs. Graph the data on the graph provided. Find the changing cost with respect to time. Okay. So the first part sounds pretty easy. The second part, the wording's a little weird for most of us. So let's see. We're going to graph the data. So I've got time and cost. That makes sense because the first variable is your x variable. So it goes on the x-axis. The second one's the y variable, so it goes on the y-axis, just like we have it labeled here. So I need in 14 minutes, they charge you $7. Okay, so 14 minutes. Now, if you're having trouble making sense of the scale, feel free to add some other numbers in. Like I know between 0 and 8 is 4, 8, 12, 16, 20, 24. I'm counting by fours. 24, 28, 32, 36. And it looks like it's the same scale on this other axis. So I might as well just go ahead and throw it in there quick. It might save me some time down the road. Alright, so now the scale makes a little bit more sense. I'm looking for the point 14, 7. So 14 would be between 12 and 16. So in 14 minutes right here, they would charge about $7. So I'm in ghost mode here for a second. Here's my 14 minutes. I want to go up to $7 right about here. And that's my point. That's the point 14, 7. Okay, next point is 20 minutes, $10. 20 minutes is here. So if I go for 20 minutes, I'm going to go up to 10. So $10 would be between 8 and 12. So if you imagine my dotted line here and my 20 minutes here, they meet right there at that point. Boom, boom. Next one. 32 minutes and 16 bucks. I'm sorry, other way around. No, I'm right, yeah. So 32 minutes. Oh, that was easy. That's 32 minutes right there. $16. Ooh, that's easy too. So let's just do that right now. So 32 and 16 crisscross at that point. Last one is 40 minutes. There's 40. $20. There's 20. All right. So what do you notice about these points? I notice that they appear to be in a fairly straight line. Now, I graphed by hand. Ooh. Let me see if I can shore this line up a little bit. So I graphed by hand. So obviously all the points aren't going to be exactly right. But I'm positive about, change color, this point here and this point here, because those are right at those intersection points, called lattice points is the name. Because 40 minutes and $20 is exactly there, and 32 and 16 was exactly there. This one was an estimation of 20 and 10. This was an estimation of 14 minutes and $7. But I know those 2 points are right on. Look at the other two. They're very, very, very close. All right, so I have graphed those points. as the directions told me to do so. The second thing they say is to find the cost with respect to time. So the cost, changing cost with respect to time is a ratio. Change in cost over change in time. That's going to be our slope. Change in the y variable over change in the x variable. If I use just these 2 points, I'm going to pick those two because those two look easy. From one point to the other, I can just go up 1 over 2. Up 1 over 2. Now, if I told you the slope was 1 over 2, I'd be lying to you. And you're going, why? Why is that wrong? Because in all the other problems that we did with the graph, I went up 1 box and over 2 boxes, and it was the right answer. Yes. This is one of those scenarios where the counting box method works, but you have to be careful. Even though we went up 1 box and over 2 boxes, we were not paying attention to the scale. Okay, let me move these 2 red dots. I don't need them. They're just kind of in my way. We were not paying attention to the scale. So from this dot here, we went up and over. Now, let's look at our scale, our units on the side. I'm going from here up to here. That's 1 box up, but how many units is that? I went from $16 here up to $20 there. How far up did we go? Well, 16 to 20 is up 4. We went up 4 units. It's 1 box, but look, each box is 4. 4, 8, 12, 16. We're counting by 4s. Here, I went from the number 32 minutes up to 40 minutes. How much of a change is that? That change is 8. Okay. So I went up 4 units over 8. Up 4 over 8. And you're looking at that going, but Mr. Henry, if you simplify 4/8, don't you just get back to 1/2? Why did we have to go through all of this? Because that does not always work. It does not always turn out that if you simplify this, you get that as an answer. It worked out here because the y-axis and the x-axis had the same scale. They were both counting by 4s. That does not always happen. In fact, that rarely happens that they have the same scale. So you've got to be very careful that you're not just counting boxes, especially in a word problem. Check the scale, the units. So slope is 1/2. That is the change in cost with respect to time. So the change in cost is $1 for every 2 minutes. Change in cost with respect to time. That's probably on their sign that says how much they charge for you to use their internet. They probably have a sign that says $1 is for 2 minutes. Or, yeah. Letter B. At Sam's Club, you can buy 10 ounces of green beans for $1.50. If the cost of green beans is constant, estimate how much it would cost for a 35-ounce can of green beans. Okay, so go ahead and pause the video. Try this on your own. And then probably you're going to have to make some predictions. And then we're going to go through it. We're going to see how we can do this, maybe with a little bit of trickery if needed. All right, so here's how most of you probably started. You probably started by looking at your graph, looking at the data, going, okay, well, I've got this 10 ounces of green beans for $1.50. And so you said, okay, 10 ounces is here, $1.50 is right there. Boom, I got a dot. And you go back up and it says, what is the cost for 35 ounces? And you go down, look at your graph and go, I don't even have 35 ounces on here. How are we supposed to do this? Well, I know another point. So, as you could probably guess, this has to do with slope, right? There's another point that I know. I know that this scenario would also go through the point 0, 0. Because if you buy 0 green beans, do you know how much that's going to cost? $0. So we actually have this line that goes from the origin through that point. And we can use that, and we can find the slope of that, and who knows? Maybe that'll give us what we need to get our answer. So let's try that quick. Now, I'm going to try the counting box method, which actually is going to give us the same thing as if we did the formula method. So from here to here, I'm going to go up, 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 up. Now, that's up, what, like 1, 2, 3, 4, 5. That's up 6 boxes, but I'm not going to put up 6. This is not up 6. I went from $0 up to $1.50. I went up 1.5 or $1.50. How far over did I go? I went from 0 ounces of green beans to 12 ounces. So I went up $1.50 over 12. Is that helping us out yet? Well, this is kind of an ugly slope. We could make it a little bit prettier if we got rid of the decimal. So we could say if we multiply top and bottom by 10, that would give us 15 over 120. Top times by 10, bottom times by 10, just to get rid of the decimal and simplify a little bit. Let's see. 15 fraction 120 equals 1/8. So $1 buys you 8 ounces. Does that help us get to our answer yet? Well, we can make a pretty good prediction, right? I know that it's going to be between $4 and $5 because using this idea here, $4 would buy me 32 ounces of green beans. $5 would buy me 40 ounces of green beans. Not 400. That's an OZ for ounces. So you make a good prediction. Now, that's kind of not great yet. But what we can do is we could actually use something that we used in a previous unit. And you folks have used a lot last year in 7th grade. So we found slope. Slope helped us get an idea. We're going to use a proportion. Check this out. I know that $1 buys 8 ounces. The question is asking us, well, how much would it cost for 35 ounces of green beans? I don't know. But we can solve from here, right? So if we cross multiply here, boom, boom, 35 on one side, 8x on the other, divide by 8, and x equals 35 divide 8 is $4 and we'll round it up to 38 cents. Because if this is money, you don't have 37.5 cents. So we're going to say $4.38. Which kind of fit that prediction we had. The prediction I had was that each dollar would buy you 8 ounces. Now, how else could we have solved this? Because that seemed like a long process just to get there. Well, look at this. You could have said, I know 10 ounces of green beans cost $1.50. See? And you could probably take a guess and say, how much 15 ounces of green beans cost. 12, 14, 15 be right here. 15 ounces of green beans, if you have your slope drawn properly, would cost somewhere in here. And you could add the $1.50 plus, I assume that's $2.58. Nah, my math's not right. But you can figure out how much this costs, and if you add those two together, that'd give you that. Okay, so it's problem solving. The slope to help us write the unit rate. It helped us find how much it costs for 8 ounces of green beans, and then we were able to use a proportion to finish up the problem. Some background knowledge. Summary. Summary says, how are slope and rate of change related? Think back to the previous two examples on how we used slope and how we used rate of change. Okay, you can answer that question on your own. This has been lesson 4.1. Thank you for watching.